Four fundamental forces control the universe. The strong and weak nuclear forces act inside atoms and molecules, like the hydrogen and oxygen atoms in a water molecule. The third force, electromagnetism, binds atoms and molecules together. Gravity, the fourth force, is dramatically different. You can feel gravity. It is the force of attraction connecting you to everything else in the universe. It extends across space, never going away. For millions of years, gravity trapped life in Earth's oceans. But eventually, life defied gravity as it rode ocean waves onto the land. By the 18th century, we had built hot air balloons to carry us above the Earth's surface. To challenge gravity in the 20th century, we invented jet engines, powering airplanes that could fly around the world. Then we built rockets powerful enough to defy the pull of Earth's gravity and carry 24 Apollo astronauts to the moon.
5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
Meanwhile, astronomers discovered how gravity affects the entire universe, controlling the motions of stars and the formation of galaxies. In this program, we'll pay tribute to the astronauts and astronomers who defy gravity as they uncover its secrets. Our gravity adventure began in 1962 at Rice Stadium in Houston, Texas.
We choose to go to the moon. We choose to go to the moon. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
Less than a decade later, we watched as a 36-story Saturn V rocket overcame gravity's bonds and propelled 50 tons of cargo, including 3 brave humans, toward the moon. In December 1968, the Apollo 8 astronauts saw Earth rising above the lifeless lunar surface. Our planet had lost its grip on these 3 astronauts, now orbiting another world. Also, for the first time, we saw our Earth, fragile and alone in the blackness of space, a world whose gravity no longer bound us. On July 16, 1969, the cylindrical command module Columbia, piloted by Michael Collins, carried a lunar lander on a 100-hour trip to the moon. Columbia remained in orbit while the lunar module Eagle took Neil Armstrong and Buzz Aldrin to the Sea of Tranquility. The TV journalist Walter Cronkite described the experience of all the Apollo astronauts as they explored the moon.
Here, men from the planet Earth, first set foot upon the moon, July 1969, AT. It came in peace for all mankind.
Imagine being the first geologist on a huge unexplored world full of rocks, dust, and unsolved mysteries. The lunar soil is rocky debris crushed by meteorite impacts into a substance that clings to everything it touches, turning spacesuits a dingy gray. To go farther and see more, NASA invented a battery-powered rover with wire mesh wheels, capable of exploring the moon and perhaps becoming a prototype for tomorrow's lunar dune buggies.
Good. This is really a rock and roll ride, isn't it? Never been on a ride like this before. Oh boy. I'm glad they got this great suspension system on this thing. Yahoo! Tony, this is so great you can't believe it.
Imagine being the first humans on this barren world, the first to see a place, kick a rock, stir up dust, or leave footprints and rover tracks in its timeless soil. All expressions are inadequate. The experience of a lifetime wrapped in a few precious hours in a place to which you can never return.
I was strolling on the moon one day in a merry, merry month of December. May, when much to my surprise, a pair of muddy eyes. Oh, is this a neat way to travel? Isn't it great? I like to skip along. Not me, boy. Skip. John, I'm gonna take that sample SCB number 2, my camera, and I'm heading home. Okay. Boy, is this fun.
Gene Cernan, the last man to walk on the moon, remembers.
I slowly pivoted, trying to see everything, and was overwhelmed by the silent, majestic solitude. Not so much as a squirrel track to indicate any sort of life, not a green blade of grass to color the bland, stark beauty, not a cloud overhead, nor the slightest hint of a brook or stream. But I felt comfortable, as if I belonged here. From where I stood on the floor of that beautiful mountain ring valley, the moon seemed frozen in time.
On December 14, 1972, Apollo 17 left the Taurus-Littrow Valley and headed back to Earth.
3, 2, 1, ignition. Right away, Houston.
This would be the last time in 50 years for humans to leave Earth's gravity field. Since 2000, there have always been astronauts orbiting Earth in the International Space Station, but no one has conquered the Earth's gravity pull since Apollo. Orbiting astronauts appear to defy gravity by floating, but they really haven't escaped Earth's gravity at all. The International Space Station and the astronauts inside are free falling around the Earth, traveling at a speed of almost 28,000 kilometers per hour. This is fast enough to prevent the falling space station from crashing to Earth and to keep it in orbit. Although orbiting astronauts are still bound to Earth, the floating sensation in orbit is a welcome reprieve from Earth's surface gravity. In this century, tourists will also experience this free fall sensation. SpaceX, a private company, docks its cone-shaped Dragon capsule at the International Space Station. Small private spaceships begin carrying humans into space. Larger vehicles like NASA's Orion spaceship might dock at the International Space Station before traveling to the Moon and beyond. To journey to the Moon, Orion will leave Earth orbit with enough speed to escape Earth's gravity and then coast toward the Moon and into lunar orbit. Astronauts orbiting the Moon will once again watch the distant Earth rising above the barren lunar surface. The Earth is as fragile and beautiful as it was in 1968, but our perception of the Moon has changed. This time we are here to stay. Soon there will be a new space station orbiting the Moon, a lunar orbital platform called the Gateway. This is a research station and a jumping-off point for astronauts traveling to other worlds. Astronauts on the Gateway will be the first humans to defy Earth's gravity for an extended period by living in a space station in lunar orbit. The Gateway is an all-in-one solar-powered communications hub, science laboratory, outpost, and supply center, as well as a staging point for lunar exploration and eventually for journeys to other worlds like Mars. Following Gateway, our next gravity challenge could be the construction of a lunar colony, permanently defying Earth's hold on life. A world with only a sixth of Earth's surface gravity cannot hold on to an atmosphere. Without air to fly through, our lunar transport has no need for wings or a nose cone. Jets will do all of the maneuvering. The airless moon is frozen in time. Here, wind and water have not erased the impacts of rocky asteroids and icy comets. The moon is a museum, preserving the scars of dramatic events in our solar system's past. Our destination is the dark cratered terrain of the moon's south pole. Here the sun circles the horizon each month, and its light never reaches deep crater floors. Astronomers work on the moon's far side, escaping Earth's stray light and radio chatter. Perhaps these lunar radio telescopes will detect signals from distant alien worlds. We can cast the moon's surface material into beams, rods, plates, tubes, and glass fibers. Solar cells made of lunar regolith collect sunlight to power our colony. On a world without life, there is no wood for buildings and no ancient life to become oil, coal, or natural gas. With no wind, waves, or fossil fuels, solar energy is our only readily available power source. Our colony lies near the rim of Shackleton Crater at the moon's south pole. The low sun's light never reaches the crater floor. Any ice brought to the moon by comets is still here. We mine this crater for this ice, which we can turn into water to drink and oxygen to breathe. We will live in an enclosed biosphere with a recycled atmosphere balanced for humans and plants. At the South Pole, the low sun circles the horizon once every month, providing uniform light and energy. Glass panels shield colonists from the most dangerous solar radiation while holding in air and water. On a low-gravity world without weather, our buildings can be lightweight and easily constructed. If you jump into that pond, your splash would be 6 times higher than an Earth splash. Here, trees absorb carbon dioxide and provide oxygen to breathe. We will also plant vegetable gardens to grow our food. On the low-gravity moon, we lose most of our weight. In the air of this dome, humans wearing wings can actually fly, gliding like the flying pterosaurs of Earth long ago. Tomorrow's Lunar Olympics will break all terrestrial records, featuring pole vault 6 times higher, long jump 6 times farther, and weightlifting of over an Earth ton. Here, graceful gymnasts can leap much higher than they can on Earth and slowly fall to the ground. Life on the low-gravity moon might become so pleasant that astronauts dread returning to the oppressive surface gravity pull of Earth. There are other worlds in our solar system, each in a unique path defined by its distance from the Sun. Planets farther from the Sun experience a weaker gravitational force, move more slowly, and have longer years. Orbital periods range from 88 Earth days for nearby Mercury to 248 Earth years for the distant Pluto. Every surface you can walk on, from Mercury to Pluto, will pull less on you than the force of Earth's gravity, holding you down right now. On Mercury, you would lose about 2/3 of your weight and could easily zipline across a crater. On Venus, the surface gravity is about the same as Earth, but you would have to live in the clouds above the planet's toxic, scorched surface. On Mars, your lighter weight would make it easy to rappel into the canyons of the Valles Marineris, one of the planet's most dramatic surface features. On an asteroid like Eros, you would weigh almost nothing. After you jump, you would need a tether to return to the asteroid's surface. On Jupiter's moon Europa, the gravity pull is much less than on Earth's moon. Here you could easily go spelunking in an ice cave, looking for signs of alien life. On Saturn's moon Titan, you would weigh 1/6 of your Earth weight and could easily power glide in the moon's Earth-like atmosphere. Uranus's moon Miranda has a very low gravity pull. Here, jumping off Verona Rupes, the solar system's tallest cliff, would result in a long, slow, majestic fall. This cliff is taller than the height of Mount Everest above sea level. In the low gravity of Neptune's moon Triton, you could use your jetpack to explore erupting ice geysers as they resurface this moon. On the distant Pluto, you're so light that skiing would be wonderful, especially if you arrive when Pluto's atmosphere snows out. All ski jumps would be a slow-motion delight on this low-gravity world. Earth traps us on its surface, but freedom is as close as the neighboring worlds of our solar system. We just have to defy Earth's gravity, as the Apollo astronauts did. In 1977, a rare alignment of the outer planets allowed the Voyager 2 spacecraft to ride the force of gravity from Jupiter to Saturn and then to Uranus and Neptune. In this gravity assist, the spacecraft grabbed a bit of energy from each planet's gravity field to increase its velocity and change its direction. Voyager 2 gained enough speed to escape the Sun's gravity forever. But where does the Sun's gravity stop? What lies beyond Pluto? Now we have found objects much farther away. Dwarf planets in orbit around the Sun at more than 3 times the distance to Pluto. One object, nicknamed Far Out, takes 1,000 Earth years to orbit the Sun. The orbit of this tiny body may play a big role in the discovery of other worlds, even farther from the Sun, but still held by the Sun's gravity. Gravity is at work on a more dramatic scale in stars like our Sun. Gravity holds the Sun together as energy rises from its core. Gravity pulls most of the matter ejected in loops and arcs back to the Sun's surface. In the Sun's core, the inward gravity push from the matter above creates enough heat and pressure to crush hydrogen into helium, trading mass for energy, and generating light to illuminate the solar system. To visualize the Sun's gravity, we must imagine space as lines extending in all directions. Now, add the Sun, and watch how these lines bend inward, creating a dip called a gravity well. The well is deeper for more massive objects like the Sun and giant planets. Gravity wells collide when twin stars are close together. Here, the stronger gravity of one star can pull matter off the other. The extra mass can make the star unstable, leading to a massive nuclear explosion. When the core of a massive star collapses, its intense gravity can produce an escape velocity surpassing the speed of light. We use the term black hole to describe such an object. A black hole's gravity traps everything, even light. Although we cannot see a black hole, we can observe how its gravity pulls on any visible companion. We have recently confirmed another characteristic of gravity: the production of gravitational waves by orbiting objects. In 2017, our LIGO detectors measured the gravitational waves produced by two very dense orbiting neutron stars. As the neutron stars moved closer together, the increased gravity pull caused them to orbit faster and emit stronger gravitational waves. This process led to a cataclysmic collision called a kilonova. This kilonova produced gravitational waves rippling across space and through the Earth. We detected our planet trembling slightly as the space-time warp of gravitational waves passed by. At a distance of 130 million light years, the gravitational waves from this event generated a space-time distortion less than the width of a hydrogen atom. Gravity causes space-time to vibrate and undulate like an object falling into water. Gravitational waves are kinks or ripples in the cosmic space-time ocean. At the beginning of the universe, gravity was there. Gravity from dark matter created structures where galaxies form. Mysterious voids separated these islands of matter. Wherever there is mass, there has always been the force of gravity controlling its behavior. Until now. Life first challenged gravity as creatures crawled out of the sea onto the land. Finally, at great energy cost, we built rockets to overcome Earth's gravity and leave the planet. We celebrate the moon missions of Apollo because they represent our victory in life's ancient quest to defy the force that has defined our lives and shaped our universe: gravity.